In this video, I want to take a look at accessing the random seed and random functions within Substance Designer to allow us to very easily create quick and seamless variations of information in our projects. So here we can see I've got a value processor node, and if we take a look, it's just a float 1 of a value of 1. And so in order to access the random functionality, all we have to do is go and search for random, and we're going to select the first or top node here. And if we take a look at the tooltip, it's going to tell us that really all this node is going to do is generate a floating value between 0 and our entry value. So in this case, it's going to be between 0 and 1. So if I right click and set this as output, now we can see that our value is actually much closer to 0, and it's going to just be a bunch of random digits. So we can see that the function is actually working. But how do we access this value and change it into a different random value, right? So if I come back out to my pixel graph here, and I go and click on our value processor node, in the base parameters of this node and many others, you'll notice that there's this random seed slider, and you've probably seen this before. And so if I go ahead and bring this up, we'll notice that the value is going to change, right? And we'll see that this value right here is 0.010. However, notice that if I go up to a different value and then back down, right, it's still going to give us the same random value. So that's something to be aware of, is that as we're navigating the random seed slider, while each new interval is going to be a different random number, each interval on the slider is going to be mapped to a specific one. So if I was to come back to this value of 4 on the random seed, it's not going to generate some entirely new random value. So how can we go ahead and use this random value that we're getting via the random seed to drive new and interesting information in our graph? So I've got this uniform grayscale color down here, and I've just created an input value of a float 1 type. So I'm going to quickly just override this with our input value, and let's go and plug our value processor in. So now, visualizing our color and changing the random seed of our value processor, we can see that the random values that we're going to get are actually going to drive the color randomly of this uniform grayscale node. And finally, there's one last thing that I want to show you about random seed before we really dive into things, because there's really two distinct ways that we can access the random seed for use in a typical graph. So if I go ahead and duplicate our value processor here, right, we'll notice that they're both going to be at the same value with a random seed of 5. However, if I go ahead and start manipulating the random seed of this node here, it's going to act locally. So we can see that as I bring this down right to 2, it's going to change the value here, but it did not change the value of our top value processor. Now, that's going to be useful if you want to keep the randomness local, but what if you want to go ahead and change all of the values randomly across any of the nodes that use and access this random function? Well, just like we access exposed parameters in a graph, we can do the same thing here. So I'm going to double click in my graph, and we'll notice that we have the random seed parameter or property in the graph properties as well. So now when I go ahead and change this random seed, it's actually going to change both of our nodes here. And so what we can use this global random seed to do is really just transform any of the nodes within the graph that access this random function so that we can just generate new random values for everything in one go. So that's something to be aware about, whether you want to access things locally at a node level or you want to access them globally at a graph level. Now let's take a look at a more practical example by creating a function that's going to allow us to give random colors without actually changing the alpha channel. So if I come into our value processor node, again, we're just going to have a simple float 1 value. And now if we're thinking about our uniform color here, right, we can see that it's going to be 4 different float values. So at the end of the day, we're going to need to consolidate all of this information into a float 4 value. So how do I go about randomizing the 3 different channels, right? Well, we've seen how to randomize stuff. All we have to do is go ahead and add a random node, and I'm going to want the values to be between 0 and 1. So I'm going to use this float1 value, and I'm going to just duplicate the random 3 times so that we can randomize the 3 different R, G, and B channels. So I'll go and plug in 1 to all of these so that the range is going to be between 0 and 1 randomly. And I'm going to go ahead and just create another float node. Now we could just use the information here because ultimately we're going to just be using a float value of 1. But to try and keep things a little bit more straightforward, I'm just going to use a second node. So ultimately, this is going to be the function for our random colors, right? We have a random red, we have a random green, and a random blue, but our alpha is going to be locked at a value of 1 or opaque. So now how do we go about reconstructing this into a vector 4? Well, I'm going to go and add a vector float2 node so that we can start to add together our red and our green. I'll then go ahead and add a vector 3 so that we're now constructing a vector 3 node. And we're going to add both our red and our green with our blue channel. And then finally, we're going to need a vector 4 so that we're going to take all 3 of those channels and add them or glue them back together with our alpha channel here. So that now I can go ahead and right click and set this as output. And if we come back to our graph, we're going to be accessing a float4 with random values for each of the colored channels. So let's quickly just create an input value here and make sure it's on float4. And let's just override this onto this property here, and we'll plug this in so that now it looks as if we're going to get a random blue color. So if I go ahead and change the random seed again of this local node, and we can really bring this up to whatever values we want, and it's just going to continuously add and change the random RGB values. Let's go ahead now and take a look at how we can use random functions to author different extents or limits for a range. Value ranges determine behavior between minimum and maximum values. Using simple math operations, we can transform our working range. Multiply scales the spread of a range, where add or subtract shift the position of a range. And so what I mean by range is if we take a look at this transformation 2D, in the offset properties here, we can see that we have x and y. And so if I go ahead and start to slide this around on the x, right, we're really interacting with a range of negative 0.5 all the way up to positive 0.5. And so what I want to do is create a function where once we go ahead and play around with the random seed, it's going to create different range lengths or range extents so that my new range may be 0 to 0.31 or from 0 to negative 0.4. We'll go 45, 44, really any kind of random range here. So how we can go ahead and start to do that is if I come into my graph here, I'm going to call this random offset range, and I want it to be of a type float1 and at a default value of 0. So the first thing I want to get is going to be our custom variable that we just created. So let's go ahead and get float and select that variable. Now from that range on that slider that we're going to go from 0 to 1, I want to grab a random value, and so that we can just essentially draw random values from the numbers that we're actually giving it. So we can go ahead and create a random node there. And now we're going to have to essentially construct a vector 2, because if we go back to our transformation 2D node, right, this is going to be a vector 2, and this is going to be the value that I want to override. So very easily, we can just create a vector float2, making sure to plug our random value into the x value here, or the top value. And I'm just going to create a float1 and leaving it at a value of 0 because we're not going to want to access the y here. So let's right click and set this as output. Come back to our functions here. I'm quickly going to have to change our input value to be a float2. And let's go and just override this, so that now when I come into my parameters here, we can see that I can bring this all the way up and start to play around with our random seed. And say we can go right here, right? We can see that this is going to be our x value. And as I bring this down, I've essentially just remapped this entire range so that we're going from 0 all the way up to a value of 0.87. However, something you might notice is that playing around with the random seed, we're only going to get positive numbers, right? So what that means is that anytime we want to get a random offset, it's only going to be essentially pushing our square here to the left side. So how do we go and actually expand this random range to actually include negative ranges as well? So back here in my function graph, we're going to have to do a little bit of editing between our random value and our final vector output. So from our initial float that we're getting, our custom variable, let's go ahead and create a division node here. And I'll just drag this down. And let's create a float 1 as well. And let's give this a value of 2. So essentially what we're doing is taking whatever input that we've created on our slider over here, we're going to divide it in half, and then we're going to subtract it from the random value that we're getting here. So that now whenever we change the random seed value, there's a 50-50 chance each time that the final output value is going to be either a positive or negative float 1 value. So now when I come back to our graph here, and we scroll all the way down to our parameters, we can see that as I bring this up, right, we're still working in the positive direction, but as I play around with it, now we're going to have negative values. So now I can move this towards the right side. And it's going to depend on which random seed interval that you're going to be at. So it's important to remember that random seed here is going to be an indicator for which direction we're going to be moving this range in, as well as the limits or the extent of that range. And this float value here is going to act much like a position random slider in a tile sampler node, controlling the maximum variation limit for this range. Let's take a look at one final example where we're going to be able to use randomness to drive and alter different variations for ranges within our project. So in this example, I want to go ahead and develop a function that's going to allow me to once again play around with my random seed to drive the direction as well as the extents of a particular range. And in this case, it's going to be for a color. So we can see here that I have this kind of like mid greenish blue color. And so what I want to do is use the random seed to give me 1, a direction to move on this hue, and 2, give me an actual final limit to know how far I can actually travel in each direction. And then from there, we just have a very simple slider that's going to allow me to move and alter our hue along that range that we've specified with the random function. So I've gone ahead and just created these parameters here, one for our color, which is going to be a float 3, and one for the hue variation slider, which is just a float 1 with a default value of 0. So I've gone into our value processor, and the first thing that I want to do is actually get the color that we're giving this parameter here, because we're going to need to use that as the basis of our range. So I've got a getFloat3 here, and let's go and just select that property. And now by default, we're going to be working within RGB space, but it's a little bit difficult to actually alter just the hue when working in the RGB color space. So what we have to do is go ahead and just convert that to hue, saturation, and lightness. So I'm going to start typing in RGB2, and you can see that we can actually convert it to a couple different spaces here. So let's go ahead and change this to hue, saturation, and lightness, so that now any of that color information that we're getting from that parameter is now going to be operating within the HSL space within this function graph. And now in order to access only the hue, we need to go ahead and swizzle these values out. So from our RGB node here, let's go ahead and type in swizzle float 1, and this is going to be for our hue. And I'm going to do another swizzle node, but this one's going to be of float 2 because this is going to be our saturation and lightness. And so let's go ahead and just quickly change the X to be Y and the Y to be Z, right? So that these are actually getting the saturation lightness, and this is going to get our hue. And now I've gone ahead and just set up this little subsystem here because it's the exact same process we used in the previous example to go ahead and give our range the ability to access a negative range. So now we want to go ahead and just make sure that with this get float value, we're going to go ahead and select our hue variation here. And now with these two, we need to go ahead and actually combine them onto our color values. So I'm going to create an add node here. And this part's going to be a little complex, but ultimately what I want to do is I want to take our hue value and I want to add whatever value we're creating randomly to that hue value. And that's how we're going to be able to actually define these ranges and actually change the hue value itself. So now that we've done the alterations that we're going to need for our range and our hue value, let's go ahead and reconstruct this back in to a vector float 3. So we'll go ahead and select vector float 3, making sure to plug our hue into the top so that it's going to be ordered properly. And we can plug our saturation and lightness into the bottom here so that now we're going to go ahead and get a vector 3 if we go and just take a look at our processor node here. But we're not done just yet because we're still working in hue, saturation, and lightness. And I want to reconvert that back into RGB values. So like we did with the RGB to HSL, let's just start to type in HSL to RGB, and we can go and use this node to convert everything back together. And finally, we're going to need to create a vector float 4, as Substance Designer is just better suited to work with colors that have an alpha channel. So we'll go ahead and create a float value that's going to be 1. And let's finally construct this all together with a vector float 4. So now we can set this as output. And if I come back into our graph here, we're now going to have access to a completely randomized value range that we're going to be able to use to drive just random hue variations. So let's plug this in to our uniform color, again making sure it's at float 4, and we can just override this. So now if I come over to our parameters, right, I can go ahead and change the hue. But now as I go and change the variation slider, we can see that I'm altering the maximum variation limit again. However, this time it results in a deviation from our initial hue value. So if I go ahead and move our random seed a couple down, we can see that now we're actually moving the other direction. And we're going to end our range kind of in this area over here. And so with this hue variation, it's going to just allow us to kind of sift through these values depending on the direction and the extent or limit that is going to be defined by our random seed. In this video, we've taken a look at incorporating the random function in random seed into our function graphs. We've also taken a look at how randomness can be injected into various use cases to make random variations incredibly simple. Don't forget that you can also use random seeds locally on nodes or globally across all nodes for different effects.